This video is about balancing the equation for a redox reaction in an acidic solution by a half-equation method. Let us consider this redox reaction occurring in an acidic solution. When iodide reacts with nitrate, iodine and nitrogen dioxide form. There are several steps for balancing the equation for this redox reaction. First, identify the substances undergoing oxidation and reduction by assigning oxidation numbers. The oxidation number of iodine in an iodide ion is -1, and that in iodine is 0. As the oxidation number of iodine increases from -1 to 0, the iodide ion undergoes oxidation. The oxidation number of nitrogen in a nitrate ion is +5, and that in nitrogen dioxide is +4. As the oxidation number of nitrogen decreases from +5 to +4, the nitrate ion undergoes reduction. Then separate the equation into two half equations, one for oxidation and one for reduction. Now, let us follow the order listed here to balance each half equation. For the oxidation half equation, there is one iodine atom on the left-hand side, while two iodine atoms are on the right-hand side. So we add a coefficient 2 in front of the iodide ion to balance the number of iodine atoms. For the reduction half equation, there are 3 oxygen atoms on the left-hand side, while 2 oxygen atoms are on the right-hand side. So we add 1 water molecule to the right-hand side to balance the number of oxygen atoms. Now there are 2 hydrogen atoms on the right-hand side, but none on the left-hand side. So we add 2 hydrogen ions to the left-hand side to balance the number of hydrogen atoms. Next, balance the charges by adding the correct number of electrons to one side of each half equation. For the oxidation half equation, there are 2 iodide ions on the left-hand side. As the charge of an iodide ion is a -1, the total charge on the left-hand side is -2. On the right-hand side, there is one iodine molecule which does not carry any charge. Hence, the charge on the right-hand side is 0. So we add 2 negatively charged electrons to the right-hand side. Now the total charge on each side of the half equation is both -2. For the reduction half equation, there are 1 nitrate ion and 2 hydrogen ions on the left-hand side. As the charge of a nitrate ion is a -1 and that of a hydrogen ion is a +1, the total charge on the left-hand side is a +1. On the right-hand side, there are 1 nitrogen dioxide molecule and 1 water molecule. As both molecules are electrically neutral, the charge on the right-hand side is 0. So we add 1 negatively charged electron to the left-hand side. Now the charge on each side of the half equation is both 0. Then make the number of electrons in both half equations equal. This is because the number of electrons lost in the oxidation half equation is equal to that gained in the reduction half equation. There are 2 electrons in the oxidation half equation, while 1 electron is in the reduction half equation. So multiply the reduction half equation by 2. Finally, combine the 2 half equations to eliminate the electrons. This is the balanced equation for the redox reaction.